Today we're talking about adding or subtracting fractions. So let's first discuss a few of the rules. The denominators must be the same before you can add them. You're going to add only the numerators, which is the top number. The denominator stays the same in the answers, so in other words, you do not add the denominators so they're going to stay the same in the answer until you reduce both the numerator and denominator when needed. It's not always needed. Okay, then when adding or subtracting mixed fractions, in other words, you have a whole number and a fraction together, so when adding and subtracting mixed fractions, you do not need to make them improper first. However, you may need to borrow from the whole number for subtraction. Can you make them improper and then add them? Yes, but it's really extra work you don't have to do, especially as you get into larger numbers. So let's do some practice problems. First of all, you'll notice here that 8 is our denominator for both fractions. We have 3/8 and 3/8, which is 6/8. Now let's remember what a fraction is. Let's say that's a whole pizza. I cut it here, I have 2 halves. I cut it here, I have 4 sections. Each one would be 1/4. If I cut each of those in half, I have 1, 2, 3, 4, 5, 6, 7, 8 pieces. So 6/8. Let's just look at that. I have 1, 2, 3, 4, 5, 6/8. Let's see what that can reduce to, because that fraction can reduce. And in order to reduce it, we divide the numerator and the denominator by a number that'll go into both evenly. So what number is that? That would be 2. 6 divided by 2 would be 3, and 8 divided by 2 would be 4. So 6/8 is the same as 3/4. Alright, so let's look back at the fourths again. This would be 1/4. This section here would be 2/4. And this one here would be 3/4. So you can see with this picture that 6/8 really is the same as 3/4. And so what's left over? Another fourth. And that fourth, you can see, is actually 2/8. Okay, let's look at an example where the denominators are not the same. So what you're going to do is ask yourself, what's the least common multiple, or the least common the least common multiple that both of these will go into or can become. And you can see that 4 can go into 8, so 8 would be the least common multiple. So to make this an 8, I would multiply this by 2, but whatever you do to the denominator, you must do to the numerator. So 1 times 2 would be 2, and what I'm doing here is just this part, so the whole thing doesn't equal that. And then 4 times 2 is 8. Now I can take my 2/8 and add it to my 1/8, and of course my denominator now is going to stay the same in the answer. We don't add our denominators, and so what do I end up with? 2 plus 1 is 3/8, and that particular one cannot be reduced because there is not a number that will go into 3 and 8 evenly. Alright, let's look at a subtraction example. We have 2½ minus 3/4. And I want you to notice that 1/2 first needs to be changed into fourths. So let's do that. So this would actually become 2 and 2/4. 2 and 2/4. Now, I cannot subtract 3/4 from 2/4. So in elementary school, most teachers tell you to make this improper and then subtract. But I want to get you ready for high school and for larger numbers. And so the better way when you get into larger numbers, and right now I'm not dealing with larger numbers, but what if I were? The better way would be to borrow from this whole number and pull 1 out of it. Okay, so if I pull 1 out of it, that leaves 1 left over, because I had 2. And I'm going to take that 1 I pull out of it and change it into fours. A whole would be 4 fourths. 4 fourths. Okay, so 4 fourths plus 2 fourths. So I'm going to add my 2 fourths that was here with the original fraction. 1 and 4 fourths plus 2 fourths would change this into 1 and 6 fourths. I add the 4 here with the 2 as the numerator, 1 and 6 fourths, minus the 3 fourths. Now I can work it. So 6 fourths minus 3 fourths, and let's not forget we still have our 1 here. 6 fourths minus 3 fourths would be 1 and 3 fourths. 6 minus 3 is 3. Okay, so this technique of borrowing from the whole number, just pulling 1 out of it, subtract the 1 from it, I get 1 left over, and that 1 I pull out is the denominator used here, and you make the numerator the same. 4 fourths is the same as the 1 I pulled out. Okay, so let's see why that's important. Let's look at an example problem here. Those of you that want to stick with your old method of making it improper, would you really want to make it improper if you had 683 and 4/23 minus 8/23? Oh, that would get you a great big number to try and make it improper, because to make it improper, you multiply your denominator times your whole number, and then you add the numerator and put it over this denominator. Well, that would be a lot of work. My method of just taking 1 out of this number, that would leave me 682, wouldn't it? I pulled 1 out. What's my denominator? 23. And that 1 that I took out of here would have to be 23/23 plus the 4/23. Okay, so all this would be minus 8/23. Okay, so that would equal 682, with 23 plus 4 is 27/23 minus 8/23. Wow, that was pretty fast, pretty easy. 27 minus 8, that would be, don't forget to put your whole number in there, 682 with 27 minus 8 would be 19/23. 19's prime, so we can't reduce that. And so this technique